Hello guys, this video will give you an overview of graph theory and we will be proving that the sum of degrees of all vertices in a graph G is twice the number of edges in E with examples. So here let us discuss some basic definitions based on graph theory. A graph G is equal to VE that consists of two sets, a finite set V of elements called vertices and a finite set E of elements called edges. Each edge is identified with a pair of vertices. If the edges of a graph G are identified with ordered pairs of vertices, then G is called a directed or an oriented graph. Otherwise, G is called an undirected or a non-oriented graph. We use the symbols V1, V2, V3 to represent the vertices and the symbols E1, E2 and E3 to represent the edges of a graph. So, the J associated with an edge EI are called the end vertices of EI. The edge EI is then denoted as EI that is equal to VI, Vj. We have to note that while the elements of E are distinct, more than one edge in E may have the same pair of n vertices. All edges having the same pair of n vertices are called parallel edges. Furthermore, the n vertices of an edge E cannot be distinct. If EI equal to VI and Vj, then an edge EI is called a self-loop at vertex Vi. A graph is called a simple graph if it has no parallel edges or self-loop. A graph G is of order n if its vertex set has n elements. A graph with no edges is called an empty graph. A graph with no vertices is called as null graph. An edge is said to be incident on its n vertices. Two vertices are adjacent if they are the n vertices of some edge. And if two edges have a common n vertex, then these edges are said to be adjacent. So moving on to the very first theorem of graph theory, and it says that the sum of degree of vertices in a graph is equal to twice the number of edges. That is, the summation of degree Vi is equal to 2e. So let's see how it's proved. Let there be a graph G with set of vertices. Vi is equal to V1, V2, V3 till Vn, and set of edges are equal to E equal to E1, E2 and E3. We have taken the total number of edges as E, as we know that the edge in graph G contribute 2 degree, that is, loop with an edge E1 contribute to degree to vertex V1. Edge with two vertex contributes 1 degree with each of them. Therefore, a single edge contributes 2 degrees. One edge is equal to 2 degree or 2 into 1 edges. E edge is equal to 2 into E, that is E is equal to edge, the total number of degrees. So let it be the first equation. The total degree of graph G will be degree of V1 plus degree of V2 till degree of Vn, or we could also say the degree of V1 plus degree of V2 till degree of Vn is equal to total number of degree. Let it be the second equation. From equation 1 and 2 we can find out the summation of degree Vi is equal to 2e. Hence, it is proved. So let's see how this theorem works in a problem. The sum of degree of vertices in a graph is equal to the twice the number of edges, that is sigma degree Vi is equal to 2e. Here in this given diagram, edges are equal to E1, E2, E3, E4 and E5. The number of edges is equal to 5. Let us find out the sum of edges. V1 is equal to V3 and V2 equal to V3, V3 equal to V1, V4 equal to 3, and total degree is equal to 3 plus 3 plus 1 plus 3, that is equal to 10. The 2 into edges, that is 2 into 5, is equal to 10. So the LHS is equal to RHS. Therefore, we have proved this theorem. So we are going on to the example 2. In this example 2, the given graph edges has A, B, and C, and D, and E. To find out the sum of degrees, first there is A, that is equal to 2. Then there is B, this is equal to 2. Then the C is also equal to 2. And when coming on to the D, we have 3 and E as 1. Therefore, the total number of degrees is equal to 2 plus 2 plus 2 plus 3 plus 1, that is equal to 10. From the proof, we can see that the result is twice the number of edges. The number of edges is equal to 5. Therefore, 5 into 2, that is equal to 10, which is equal to the sum of degrees. So let us on to the proof to the given theory. We can see that the result is twice the number of edges. The number of edges, 5 into 2 is equal to 10. So let us go on to the proof of the given theory. In any graph G, the sigma d of V is equal to 2n. Let us consider a graph having n vertices and n edges. It is clear that each edges contribute degree of 2. Therefore, the sum of degrees of all vertices is equal to the twice number of edges. That is, the sigma d of V is equal to 2n. Here, the sigma d of V is the sum of all degree of vertices of G, and ne is the total number of edges. So that's all, and thank you everyone, and have a pleasant day.